Let's imagine a situation where you got a nullable string from somewhere. So you have something like var s string question mark, and maybe you got it from some other API. I'll just initialize it to something so the compiler doesn't complain. So you have a nullable string, which means it is now illegal to print line s.length, because after all, s can be nullable and null.length doesn't make any sense. So one of the ways you could mitigate this is you could check for null. So you can say if s is not equal to null, then we can perform certain operations. Now the trick that Kotlin does is once you've checked that something is not null, it switches off this checking. So if I now print line s.length here, this would be completely valid. You wouldn't have to perform any additional operations on s because we are in a block where we already checked that it's not null. Therefore, the additional checks here are disabled. This idea of float-based typing is all over the place in Kotlin. Let me give you another example. Let's suppose that I make a variable called x, which is an int array of 1, 2, and 3. Now let's suppose that instead of an int array, I got some other super type instead. So for example, I maybe got a clonable, for example. So I know that if I can cast x to an int array, then it is in fact an int array. So once again, the situation is that if I try to print line x.size, you will see that x does not have a property called size. Therefore, this is illegal. However, as soon as I check that x is in fact a int array, I can now print line x.size because the compiler knows that we've checked that it is of a particular type. Therefore, I don't have to write x as int array.size. I can just, and you can actually see that the compiler or the IDE tells you that this cast is not needed. So we can get rid of it because as soon as you've checked, you can start using it as the type that you've checked against. And this is great. This saves you a lot of trouble and a lot of typing as well.